Okay, so here we go with video number 2. We're going to have a look now at how we form nitriles. So our nitrile is the functional group of carbon triple bonded to a nitrogen atom, and quite often we might see this also written as a cyanide ion, Cn-, and you can see that that negative charge belongs to the carbon because it's the carbon that's going to be forming bonds. Nitrogen's using up all of its electrons, its valence electrons, in forming that triple bond with the carbon atom. Quite often in reaction mechanisms we might find hydrogen cyanide mentioned. Hydrogen cyanide is a very poisonous gas, so the reality is it's not going to be used. We might find potassium cyanide or sodium cyanide used, and seeing it described as acidified, often using something like sulfuric acid as the source of those H+ ions. Our cyanide group is going to carry out lots of nucleophilic substitution reactions, so the place where you need to be able to use them is looking at how our haloalkanes can have the halogen that's present substituted with the cyanide to form a new molecule that's going to have the nitrile group present, and that's going to have an additional carbon added to its chain length as well. So quite useful and quite interesting. Let's start off with a simple example. I'm just going to start off here with chloromethane. And the conditions for this change to happen are cyanide in the presence of ethanol. So this is going to be something like potassium cyanide again. And with our chloromethane that we've got present, we need to remember that this bond here is polar. Our chlorine is more electronegative than the carbon, so we have a dipole, and that's going to create that little bit of diversity, not quite instability, but it breaks up the symmetry of the molecule, which is going to allow a nucleophilic substitution to take place. So we're going to see attack from that negative charge on my cyanide to the carbon, and the movement of electrons from the carbon onto the chlorine to form a chloride. And we're going to make a new molecule that now has an extra carbon in its chain, and that we're going to call ethane nitrile. Don't forget, we also have to show that we have a chloride ion produced as well. So this is our simple mechanism. I'm going to ask you to have a go now with a couple more examples. So after you see them appear on the screen, pause the video, have a go for yourself, and then I'll show you those mechanisms in just a moment. So I'd please like you to have a go at predicting the products of bromoethane, iodopentane and chlorobutane with ethanolic cyanide. Have a go at those. So here we go with our first one of those, bromoethane. So I'm going to keep my bromine on the right just because it's in a good position to then show the substitution with my cyanide. It's going to attack because the bromine is more electronegative than the carbon, which creates that little bit of asymmetry so that my cyanide can attack the carbon. Movement of electrons onto my bromine, and I'm going to see after my 2 carbons from my ethane that I then have addition of that 3rd carbon from my nitrile group. Mustn't forget to put in my conditions, and remember to include my halide ion that's been produced at the end. Have a look at your next examples, make any alterations if you need to, and I will go through those next. So the next one I asked you to try was the reaction of iodopentane with ethanolic cyanide. So let's have a look. I'm going to keep this simple by just including those groups and then summarising the rest of the molecule off to the left there. I always like to try and draw the bonds between the carbons because that's where they'd exist. It's just slightly more accurate. we're going to include our conditions, ethanol, and our source of those cyanide ions. And my cyanide exists with that negative charge on the carbon. Remember to show my dipole. The negative charge attacks the carbon with the movement of electrons onto the iodine to create iodide. And then I'm going to make my new even longer molecule, because that nitrile group's just going to replace where I had the iodine before. Make sure I've included all my hydrogens and that iodide that was lost. So hope you worked out yours as something similar. Let's have a look at the third one. And we've got the reaction of chlorobutane with ethanolic cyanide. So again, I'm just going to keep this simple. So my chlorine joined to the carbon bond, 2 associated hydrogens, and then because this is butane, I'm just going to show my little propyl group sat on the left hand side there, because that's not so involved in our reaction. My reaction arrow, put in my conditions, label up my dipole and put in my nucleophile, arrows to show the movements of those electrons, and then let's extend that carbon chain by the addition of my nitrile group. And don't forget to include your other product that was made, that chloride ion. Hope you've gotten all right with that. In my next video, I'm going to look at how our cyanide or our nitrile attaches across a carbonyl group. So I'll see you again shortly. Well done.